Assalamualaikum and good day to my lecturer Dr. Membra Hitom and also my group mates. So today me and my group mates will be presenting our project. We do prosthetic legs prototype for BFF3593 Additive Manufacturing. Basically, prosthetic leg has been a crucial aid for amputees to restore their mobilities to move. For these current methods, we do prosthetic legs that involves time-consuming, and this will become more expensive to manufacture the final product. So, with the images of 3D printing, the process can become faster, cheaper, and more customizable. And also for the problem statement, the first one is we discovered that not all amputees have access to 3D printing technology, which causes to unequal access to high quality manufacturing of prosthetic legs. Next, we discovered that the use of 3D printing in prosthetic leg design is still relatively new and in developing field. So there will be a lack of standardization in terms of quality and safety. And the last one is the process of 3D printing prosthetic legs can be time consuming and expensive. So we afraid that this will burden the amputees. So for the purpose, we want to provide amputees with more accessible, affordable and personalized prosthetic that can improve their movement. And we want to enable the creation of prosthetic legs with more complex design with the use of 3D printings. And also we want to increase all the access of high quality prosthetic leg, and we want to improve the overall experience of the amputees to use the prosthetic legs by using 3D printing technologies.
We have a 3 concept design for our prosthetic leg. The concept 1 have a 3 part, the concept 2 have a 4 part, and the concept 3 have a 3 part.
Next, for concept selection, concept 3 have been selected for our project because this design is user-friendly and comfortable. It is suitable for weight between 40 to 50 kg and can be used for running, hiking, jumping, and walking. It is also more stable and safer, as well as may improve quality of life. All these statements can be proved by doing FEA, which will be present in the next slide.
This is finite element analysis. We each FEA before we print this part. The FEA was done after do a topology to get a final design. There are 3 analyses with each displacement, 1 basis test, and equivalent strain. The result for this analysis show that this prototype will support the weight 40 kg until 50 kg.
Okay, for prototype design consideration, we have 4 items we consider. The first one is the scale, the second one is the thickness of each layer, and then the fourth one is the orientation of the product, and the last one is material selection. Okay, for the material selection, we choose the ABS because ABS is the common 3D printing prosthetic leg, and they also have several of advantages, which is the first one is ABS is low cost, second is strong and lightweight, and then the third one is available in various color, and then good impact and wear resistant, and the last one is good heat resistant. The bill of material of our product is have 5 parts, which is the part A, part B, part C, and part D, and also the part pin prosthetic leg. So every part have a 1 quantity only, and the all materials we use ABS.
This is assembly model before do a topology optimization. This is our design for assembly model, and this is a dimension for assembly model. This is a 3D model before do a topology optimization, and for this model we have a 5 part, and this is a design, and this is a dimension for a design before do a topology optimization. This is a assembly model for after topology optimization, and this is our design, and this is our dimension for our product. This is a 3D model after we do a topology optimization. We have this design, and this is our dimension for our design.
For the functional criteria, which is main parameter of our product, we are focusing on the strength of the prosthetic leg because the product will long-lasting and have a better quality. Based on the FEA results, our product has a good strength and withstand the considering load. The second parameter is energy efficiency of our product, which we are aiming to minimize the energy use as appropriate joint alignment will reduce fatigue and discomfort.
For module 2, I have been given the task to do orientation and also support structure. As you can see here, this is the orientation of the 3D model that we have designed by using CATIA, and also after that we convert it into STL format and we transfer it into Ultimaker Cura. So we want to see how the legs are made before we do the printing process. So these are the isometric view, front view, left and right view, and also the top view. And also for the support structure, after we do a slicing process, we can discover that the support system and the support structure of the prosthetic leg that we want to print has been generated. As you can see, the turquoise here presents the support that we print, that it will be printed for the process. So as you can see here, the support helps in printing the structure so that it cannot topple easily.
Topology optimization process. For the topology, we do one design because this design have a lot of material. So the original mass part is 0.949 kg. We do a mass reduction 40%. Then the final mass is 0.5 C9 kg. So we can see for the this topology, it suggests to do a cross-section design, but we observe this cross design is not strong. So we adjust this topology, and then we get the final design for the topology. This is a new design, use a topology optimization.
For the printing parameter setup, we have 3 parameters. The main parameter, which is the first one, is speed. We use 50 mm per second for high quality print. The second one is infill. We use 80% for infill density because can be our prototype more stronger and more durable. And the third one is wall thickness. We print in 0.8 mm wall thickness. The reason behind this number is the part they are printed with a single wall can be formed, effective part strength and dimensional accuracy, and provide strong part. For the support structure removal, as you can see at the slide, we use 4 tools, which is the first one is needle nose plier, flash cutter, scraper knife, and expert knife. So we remove all the support, and then after we remove, we use a panel to sanding off the surface to be smooth.
Alright, for module 3, I've been given the task of painting. So for the painting, we decided to use brown color because it can imitate the amputee's leg color. And also, we want to help to making the visual of the prosthetic leg become more vibrant. As a matter of fact, adding colors, we can identify which part of the model are moving, whether it's moving on in stationary state. And also for the painting, we use air spray for the prosthetic leg model.
Next, as you can see in the video, this is the testing functionality of our product. The connected part moves to front and back as it is the main motion for human movement, and we can see that our product is successfully functioning. For further improvement of our product quality, in my suggestion, exchange the design of pylon part by redesigning it into one cylinder shape with larger diameter and hollow inside. Next, adding an adjustable mechanism at the pylon part, which are height adjustment or rotational alignment, will ensure the optimal stability and comfort for the user.
Further improvement of the product quality. First, change the design for the foot movable, which is add a pin instead of a plug-in method to ease the movement of a prosthetic leg. Second, add a regenerative effort assistive smart pylon RSP with a smart foot adapter. With height variable suspension for the amber walking can reduce the strain on the input stump, prevent the injury to the soft tissue of the stump or the formation of a scar.
The last one for further improvement for product quality, our prototype, which is the joint part, which is we have to change the pin like the picture as you can see, because for our prototype we use a pin inside and it can be cracked. So when we change into the picture, as you can see, so the leg will be supported. So that's all from us.